I'm going to explain that again because I wasn't recording. We're doing a review of the parallel lines. So I'm going to have you guys find the measurement, or find x and y using what we know about the parallel lines and congruency. And then I told you that the measurement of angle 1 is 3x plus 15. The measurement of angle 2 is 4x minus 5. And then the measurement of angle 3 is 5y. If you guys want to look in your math packets for like help, it's the stuff about parallel lines is on page 2. Okay, we're going to start going over this. But to solve for x, I'm going to use measurement of angle 1 and then the measurement of angle 2. So those are actually corresponding angles, so we can set these equations equal to each other. Over here I'm going to write 3x plus 15 is equal to 4x minus 5. And then we'll solve for x. So I'm going to subtract 3x on both sides, so 15 is equal to x minus 5. I'll add 5 over, and then my x is equal to 20. So now I know what x is, and then in order to find y, we're going to have to do a little bit more math. So the other thing we know is that angle 3 is equal to 5y. Well, angle 3 is also corresponding with angle 1 and then angle 2, just because of where it lies with the parallel lines. So we can set 5y equal to either angle, the measurement of angle 1 or 2. So we know what x is, but we don't know the exact number for those angles. So I'm going to plug 20 into 4x minus 5. So 4 times 20 minus 5. My 5y is equal to 4 times 20 is 80, and then minus 5 is 75. So if 5y is equal to 75, I'll divide by 5 on both sides, and then y is equal to 15. Sorry if that was a little fast, but do you guys have any questions about how we got here? We're going to do one more like this. Okay. So here's my figure, and then I'm gonna have you guys, just like before, find x and y. This time I told you what, so I'll put into this angles, but this one right there is 5y minus 4. That one on the other side in this corner is 3y degrees, and then in that corner is 2x plus 13 degrees.
Sorry, what's the y one again?
Sorry? What was the question?
What's the number for y?
Oh, so you guys are gonna have to solve for it.
No, I know. I'm like, what is it, like 3? Is that a 3?
Oh, right here.
Yeah.
Yeah, that's a 3. Sorry.
Okay. Thank you.
Mhm. Okay, we'll start going over this one. But in order to find x first, we're gonna have to solve for y first. So we know that this corner right there, or that angle, was 5y minus 4 degrees, and then this one, they aren't next to each other, but that's 3y degrees. Well, this angle is corresponding to that angle right here, and we know that these two angles are supplementary. So that means that they add up to 180 degrees. So my equation is going to be 5y minus 4 plus 3y is equal to 180. And then we're going to combine like terms to solve for y. So 8y minus 4 equals 180. And then I'll subtract 4 on both sides. So, oh, sorry, not subtract. I need to add 4. Okay, add 4 on both sides. And then 8y is equal to 184. To get y alone, I'll divide by 8. And then for y, you should get 23. You guys agree? Yeah. Okay, so we found y is 23. And then we need to find x. And so kind of similar to the other one, but we don't need y. We actually need like that actual angle. So I'm going to plug 23 in for y using this one. So 3 times 23 is equal to, this angle is corresponding to this one, so I can set them equal to each other. So 3 times 23 is equal to 2x plus 13. Okay, with me so far? So I do 3 times 23, which is 69, and then equal to 2x plus 13. I'm going to subtract 13 on both sides. So we have, oh. 2x is equal to 56. And then, is this what you guys have?
Yeah.
Okay, my math was wrong.
I have a question.
Yeah.
On the bottom of 180, is that a plus 4?
Over here? Yes.
Yeah.
So I want to get y alone, so I added 4 on both sides, and then I divided by 8.
Oh, okay.
So yeah, over here, the work I had, the math I had was incorrect. So it should be 2x is equal to 56, and then if you divide by 2, you should get x equals 29. Is that right?
I got 28.
28. 28, sorry. Okay, x equals 28. You guys have any questions about how we found x or y, or just like anything? Alright, so something else that we've talked about, like, while we were doing math was the perimeter of, like, kind of like irregular shapes. So I'm going to draw a shape up here and have you guys find the perimeter. Okay. So with the shape and then the side length I've given you, you guys need to find the perimeter. Okay, let's start going over this one. So the perimeter means to add up all the side lengths together. So let's add up like what we know. So this side is 8. This one is 5. The bottom is 10. And then the left side is 13. We still don't know this side length here and then that side length there. So we have to add these. Well, we can figure it out because we know that the bottom length is 10 centimeters. So if we have a length from here to here, and then also a length from there to there, they should add up to be equal to our 10 centimeters. So we won't know like the exact like breakdown which is which, but we do know that both of them together would be 10. So if you add all these up, does someone want to call out an answer?
54 centimeters.
That's not quite what I got.
I got,
Oh, messed it up.
I got 46 centimeters.
Oh, okay. Yeah, so 46 centimeters is the answer for this perimeter. And then remember, if we're doing perimeter, it's just centimeters, but then if we talk about like area, it would be centimeters squared or like meters squared. But yeah, so 8 plus 5 plus 10 plus 13 plus 10 is 46. Okay, any questions about this? Alright, we'll do one more perimeter one. Okay, also these are supposed to be like straight lines, sorry. Okay, and this is not drawn to scale. But same thing, I'm gonna have you guys find the perimeter. Just to clarify, but 7 inches is that like horizontal one, and then the 6 inches is the vertical one. Okay, let's go over this one. So to find the perimeter, we're going to want to add all the sides together. So let's add what we know. The top is 16. The side is 12. Bottom we don't know. There's 6. And then 7. We also don't know that side right there. So let's try and find this bottom one. We know that the whole thing that stretches across should be 16. Well, if we're leaving out this part, that's 7, and we want to find this part, we do 16 minus 7, and that would give us 9 inches for the bottom side length, so plus 9. And then the last one we need to find is the one over on the left. So we know that the total thing is 12, and we don't want the 6 inches part, we just want that part up there. So we do the total minus the excess, and then we do 12 minus 6, which is 6. So that's our last missing side length. So if you add all those together, 16, 12, 6, 7, 9, and 6, you should get 56 inches. You guys agree?
Yep.
Okay. So any questions about finding this perimeter? No. Anyone online, do you guys have any questions? Okay, so we're gonna move on to an area problem real quick. So I'm gonna have you guys find the area of a rhombus, and I'm not gonna tell you the equation right away because they might not tell you on the ACT. You'll just have to remember. So I'm gonna give you this rhombus and then the diagonals, and then you guys try and find the area, and we'll talk about it. So I labeled the different points of this rhombus, U, V, S, and T, and then I told you that TV, which stretches horizontally, is 16 yards, and then SU, which is vertical, that vertical dashed line, is 9 yards. So what I gave you were the diagonals, and then hopefully you guys remember that equation. We've talked about it a couple of times, but to find the area using diagonals. Okay, so I hope you guys remembered it, but the equation to find the area of a quadrilateral using the diagonals is half times the diagonal 1, half times the diagonal 1 times the second diagonal. So that would be our equation. So let's plug in what we know. You know, one of the diagonals is 16, the other one is 9. So half of 16 times 9, you should get 72, and then because it's area, it would be yards squared. So here's our equation. Plug in what they give us, 16 and 9, and then you would get, plug that into your calculator, you should get 72. So yeah, it can come in handy to like know a lot of the like different equations and formulas because like sometimes they'll give it to you, sometimes they won't. I think I told you guys this before, but like when I was studying for the ACT, I made like flashcards with the math formulas, and then I like studied them while I ate breakfast or something. But yeah, and it really helped me. While I was doing the math test, I just like could remember them, and I think that helped me go quicker. So if that's something like you guys think might help you, you should really try it. I definitely recommend using like math flashcards. It does take a while to make them, but it's really helpful, really beneficial. Okay, any questions about this? Pythagorean theorem in here?
Yes. Wait, did we?
I don't remember. You probably.
Oh, okay.
Let's see.
I actually,
I think we did. It was
I don't think you did it with me.
not with you, probably.
No.
I know we did it.
You did do it?
I feel like we did. Where did I do it?
Oh, okay.
I remember talking about it.
Yeah, I think we did. Cause I swear we talking about it. Like you just told us about it.
Okay, we'll do a quick review because I don't think we talked about it with me. But the Pythagorean theorem has to do with like right triangles and their side lengths. So we've got the hypotenuse, which is the side directly across from the right angle, and that's the longest side. And then my A and B, which I labeled here, are the legs. So we can use an equation to find like either the hypotenuse or some of the legs of the triangle. And it has to be a right triangle. The A squared plus B squared is equal to C squared in every right triangle. And then C squared is that longest side, the hypotenuse. Does that seem familiar? Yeah. Okay, so here's that one question I wanted to do. Okay, so the question is, could 3, 6, and 8 represent lengths of the sides of a right triangle? And this, you probably wouldn't see this exactly on the ACT just because it's a yes or no, not a multiple choice. But to figure out the answer, we'd use the Pythagorean theorem to solve for it. So you guys want to try this and then see what you get. Alright, so using Pythagorean's theorem, we know that with every single right triangle, it has to be a right triangle. The sum of the legs squared is going to be equal to the sum of the longest side squared. So let's try it out with these three numbers, 3, 6, and 8. Well, 8 is the longest side length, so that would have to be C, or like the hypotenuse, if we were going to plug it into this equation. So let's try it. 3 squared plus 6 squared is equal to 8 squared. So if we were to like simplify these, 3 squared is 9, 6 squared is 36, and then 8 squared is 64. Okay, so 9 plus 36.
Saying A is 3. So I thought 3 was B.
Oh, either one could work. I could say like
Okay.
6 squared plus 3 squared is equal to 8 squared. It's just that the longest side has to be C. So A or B could be flipped. Yeah, so if we simplify this, 45 is equal to 64. Well, we all know that's not correct. 45 doesn't equal 64. And so that means that the Pythagorean theorem didn't work and that these three numbers couldn't represent a right triangle. If it were to be a right triangle, we'd get like 64 equals 64 or something like that. Yeah, I'll show you guys an example of where it would work. Let's say, like, one leg is 3 squared plus 4 squared is equal to 5 squared. Let's say my A, B, and C are 3, 4, and 5. If we were to simplify those, 9 plus 16 is equal to 25. Well then, 9 plus 16 is 25, so 25 is equal to 25. So if I have a triangle with the side lengths of 3, 4, and 5, that would be a right triangle. If I have a triangle with the side lengths of 3, 6, and 8, it could still be a triangle, but it's not going to be a right triangle. Alright, any questions about this? Sorry that we didn't go over the Pythagorean theorem, with me at least. Hopefully you guys talked about it with Manoj, but that's kind of like a quick overview. And then while we're talking about triangles, we're gonna move on to what I said. In addition to what we were talking about the last time you were with me, we were doing SOHCAHTOA. You guys remember that and the trigonometry? Okay. So we'll review that really quick and then talk about a new thing. So here's my right triangle, and then remember our acronym was SOHCAHTOA. So let's say I'm talking about this angle right here. We can label the sides that are opposite, adjacent, and then we can also label the hypotenuse. So remember that the hypotenuse is the longest side. That's one way we can identify it. And then another way is that it's always the side that's directly across from the right angle. So here's my right angle. If I go across, opposite, that tells me that this side is the hypotenuse. And that's always going to stay the same no matter which angle we're referencing. But let's say we're talking about this angle, and I want to know the side that's opposite from it. So I go directly across, and this side would be opposite from that angle. So I'll label opposite. And then the other term is adjacent, and that's the side that's kind of right next to the angle. Technically, there are two sides that are right next to the angle, but one of them is the hypotenuse we already labeled. So we've got hypotenuse, the opposite side, and then the adjacent side. And then that's where our SOHCAHTOA comes in. So that's that fun acronym to remember the trigonometry terms, which are sine, cosine, and tangent. But the SO part of the SOHCAHTOA, the sine is equal to our opposite over hypotenuse. So that ratio, that's the way to remember it. The cosine ratio is equal to adjacent over hypotenuse. And then the tangent ratio is equal to the opposite over adjacent. Okay, I know it's been a while, but did this kind of jog your memory with what we talked about? Okay. Okay, if you guys have your calculators, first thing I'm going to have you do is make sure it's in degree mode. So to check that, you press mode, and then the fourth column down it should say like radian or degree. Make sure yours is on degree mode just so we can get the correct answers. Okay. Yeah, I don't think we have time today to go over like all that we did last time, but let's just practice finding like maybe cosine in your calculator. So say I asked you to find cosine of 76 degrees.
What did you want us to do again?
So in your calculators, first make sure it's in degree mode, and then type in cosine of 76 degrees, and then tell me the answer that you would get. So we're just practicing making sure we can find like sine, cosine, and tangent in our calculators.
Okay.
I got 0.2419.
Yep. So I'm just gonna round that to 0.24, but hopefully everyone got this number out. Yeah, did everyone get that out in your calculator? Online, did you guys get that?
Yep. Yes.
Okay, good. So we talked about finding like different angle lengths and then finding the side lengths last time with SOHCAHTOA. And then today we're going to talk about something called the law of sines. And so we use the law of sines to solve triangles, kind of like how we use SOHCAHTOA to solve triangles. But in this instance, our triangles don't have to be right triangles. So when we're doing like the Pythagorean theorem, we needed to have like right triangles in order for it to work. When we're doing the law of sines, the triangles don't need to be right triangles. They can just be like any type of triangle. So here's the formula. It looks a little confusing at first, but here's the law of sines, and it's sine A over A is equal to sine B over B. So I'll give you guys a second to write that down. And in order to use it, we either need to know like two angles and one side, or we need to know two sides and one angle. You need to know at least like 3 of the 4 to solve for it. So I'll kind of break this down. But the capital letters, like this capital A and the capital B, those mean the angles. And then the lowercase letters mean their corresponding side. So I'm going to draw an example where we can kind of see it. Okay, here's my triangle here. It's got the points A, B, and C. And then what I was talking about, like the capital B being the angle and then the lowercase b being the side. So you can see here, my 1 point, this is my capital B, and that is 38 degrees. And then directly across from it is my lowercase b, and that represents the side. So in your law of sines, the capital letters are going to be the angles, the lowercase letters are the sides. And then up here, this angle is supposed to be a capital C, if you can tell, and then the one across from it is a lowercase c. I didn't label it here, but my capital A is 59 degrees, and then this 350 centimeters would represent like my lowercase a. So what we're going to do is solve this triangle. In order to solve the triangle, we kind of need to find, it means like finding all the angles and all the side lengths. Well, we know most of the angles and most of the side lengths. What we don't know is, hold on. Yeah, we don't know this angle here. We don't know this side length, and we don't know that side length. For this problem, I'm just going to have us find the side B. So we're not going to solve the entire triangle, but we're just going to find B. So to do that, we're gonna plug in what we know. Well, we're looking for side length B, and so the angle that goes along with it is that uppercase B. And then we also need to know another angle and then another side. So we know that this angle A is 59 degrees. And then we also know that the corresponding side length A is 350 centimeters. So that gives us enough information to solve for this. So let's go plug into our formula. All right, so sine of A, well, A, the angle is 59 degrees, so I'm gonna write that here. And then over our side length of A, which is 350 centimeters. That's equal to sine of B. We do know angle B is 38 degrees. And then the side length of B is what we're looking for, so I'm just gonna leave that as B. Okay, is everyone following along so far? All right, so at this point, we're gonna grab our calculators. And so how you solve for B is to cross multiply and then divide, if you guys know, if you have an unknown variable. So what I'm gonna do is 350 times sine of 38. So you wanna type that in your calculator. I guess if I were to write this out. So when I'm cross multiplying, 350 times sine of 38 would be equal to B times sine of 59. So what did you guys get for 350 times sine of 38?
215.
Yeah, so around 215. I'm just gonna round it to 0.48, but if you guys leave it in your calculator, the actual full thing, that'll be helpful to get like a more accurate answer. So 215.48 is equal to B sine of 59. Is everyone following along so far? Okay, and so what we were searching for was B. So we want to get B alone, and in order to do that, I'm going to divide by sine of 59 on both sides. So up here I wrote 215.48, but if you guys have that full thing in your calculator, like not rounded, just divide by sine of 59, and you should get your answer.
I have a question.
Yeah.
So how I was taught just at school, and I'm assuming it's the same exact thing, but before you simplify or find the answer to 350 times sine 38, I just go ahead and already divide by sine of 59 and then put all of that in my calculator.
Okay, yeah, you guys can totally do that. Yeah, that's probably a lot easier than what I was doing. But you should get the same exact answer for B. Is 251.39. I'm just breaking it down to show you how you cross multiply and divide, but typing it all in at once will definitely save you some time. Did you guys all get this answer?
Yep.
Okay. So, yeah. I think we're pretty much out of time, so we're gonna stop there today. But next time we'll go over more of the law of sines, and then we'll talk about the law of cosines, which I don't know if you guys have heard about. But for now, you guys are free to go. That's the end of class for today.
Thank you.